How to graph y equals the natural log of x. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. So y equals the natural log of x. First of all, we're going to recall the definition of what we mean by the natural log of a number. So natural log is the log to the base e, which is about 2.7 of x. And keep in mind that we can rewrite this log equation as an exponential. The base raised to the y is equal to x. So e to the y equals x and e to the x equals y are inverses of each other. Interchange the x and y's. So natural log and y to e equals e to the x are inverses of each other. So we need to realize that. So since they are inverses of each other, they're formed by interchanging the x and y coordinates. So here's our table from the exponential function, which hopefully you just did the video for that one. We did need to use a calculator to know these values. And the graph looks like this, exponential growth. So the table from the natural log of x will look like this, because we just interchanged the x and y coordinates. It's that simple. So if you know the graph of e to the x, you know the graph of y equals natural log of x. So graphing this, we'll go ahead and plot these 5 points going from right to left over 7.4 and up 2, which is e squared, up 2. E to the first power, 2.7, up 1 approximately. The x-intercept, 1, 0. And then they start getting and negative. So there's the 5 points. We'll go ahead and connect the points. And then looking back over at e to the x, we can see that the x-axis is a horizontal asymptote for the exponential function. So that would make the y-axis a vertical asymptote, because these are inverses, switching x and y. So it would look like this. Here, to the as x gets larger, y gets larger much quickly on the e to the x function. So that would be transfer over here going this direction. X could get very, very large. Y gets very, very large. We also know that these are symmetric about the line y equals x, the identity function. That's just a property of inverse functions. So here's y equals e to the x in blue. Y equals natural log of x in green. And then I'm going to put in the line y equals x as a dashed line so we can see that symmetry thing going on here, mirror image idea going on here. And showing some ordered pairs. On the blue graph, it's 0, 1. On the green, it's 1, 0. Those are definitely interchanged coordinates. And these 2 points, you can see those are coordinates interchanged. And then also here. And these are our big 4 that we will use to sketch out the curve. So if you know the graph of y equals e to the x, to graph the natural log, you could either interchange the coordinates of the graph of the exponential function and or reflect the graph y equals e to the x about the line y equals x. You have your choice there. So we're going to graph the natural log using the exponential function dance in reverse. So we know these, interchanging the coordinates. I usually like to start with the intercepts. So 0, 1 goes to 1, 0. 1e goes to e, 1. 2e squared goes to e squared 2, and then the reciprocal of e. So those are our 4 key points. We can go ahead and connect the points and then make it look like the graph should be. Y equals natural log of x. Domain and range. So we have the graph and the table here, and you'll notice at 0 this is undefined. The U is for undefined. So the domain is not including 0, but everything to the right of it has a point above or below it. So that would be the positive real numbers, and we show that as a set of all x such that x is real and x is strictly greater than 0. The range, well, we'll notice from the y's has all x's to the right of it, so it is all real numbers. Where you could find the graph of natural log in the world, here's a curve called the Preston curve. Thought that was kind of interesting. And we suggest that you interact with another video in this series.